Hey, today we're going to look at the last of our series convergence tests, the root test. Here's what it says. It says that if the limit as n goes to infinity of the nth root of the absolute value of the terms of some series is less than 1, then that series converges absolutely. And we know that series that converge absolutely converge, so the series converges. On the other hand, if that same limit as n goes to infinity of the nth root of the absolute value of the terms of the series is greater than 1, including the possibility that it might be infinity, then the series diverges. It's important to note that just like the ratio test, if this limit that we're looking at is equal to 1, the root test tells us absolutely nothing, and we need to use some different series convergence test. We'll do some examples in just a moment, but first you might notice that this looks a whole lot like the ratio test, at least in its form and format, and it turns out that the proof of the root test almost identical to the proof of the ratio test, and so we'll skip it and we'll just go straight to using the root test. Here's an example: the sum n equals 1 to infinity of the quantity n squared plus 1 over 3n squared plus n minus 3, all raised to the n. It's these kinds of examples where we've got something all raised to the nth power or something like the nth power that just cry out for the root test. I take the limit as n goes to infinity of the nth root of the terms of the series. Technically, it should be nth root of the absolute value of the terms of the series, but the series has all positive terms, and so the absolute value of the terms is just the same thing as the terms. If it was an alternating series, the absolute value would be more important. And the beauty is that the nth root of something to the nth power is just that something, and so the nth root and the nth power there cancel, and we just get the limit as n goes to infinity of n squared plus 1 over 3n squared plus n minus 3. And I'll let you decide how you want to compute that limit. You can either use algebra and the limit laws, or you can use L'Hopital's rule. One way or another, you find out that that limit is equal to 1/3. And since 1/3 is less than 1, the series that we're testing converges by the root test. And most of these root test problems are really that easy. I'll do one more slightly trickier one before I give you one to try, and then we will call that enough. We'll look at the sum n equals 1 to infinity of the quantity 1 plus 1 over n, all to the n squared power. And applying the root test, we look at the limit as n goes to infinity of the nth root of 1 plus 1 over n, all to the n squared power. And the tricky question becomes, how do you take the nth root of something to the n squared power? And the answer is, you remember your properties of exponents. Taking the nth root of something is the same thing as raising it to the 1 over n power. And then again, by the properties of exponents, the exponents multiply in this case, and n squared times 1 over n is just n, and so you get the limit as n goes to infinity of 1 plus 1 over n to the n. And this is a limit that we've seen recently, and so perhaps you remember the answer. You might even remember how to do it. It turns out that to do it, you need some sort of advanced, the most complicated possible application of L'Hopital's rule. But in the end, you find that this limit is equal to e, and sometimes people even take this as the definition of the number e. One way or another, this limit is e. And e is some number between 2 and 3. In particular, it is greater than 1. And so we can conclude that this series diverges by the root test. Okay, you try this one. See if you can use the root test to determine whether the series sum n equals 1 to infinity of 2 to the n over n to the n converges or diverges. So take a moment, pause the video. When you're ready, start it back up again. I will say that if you have trouble figuring out where to start, keep listening and I'll give you at least the first step. Otherwise, pause the video and start up again when you're ready. And the first step is to recognize that algebraically 2 to the n over n to the n is the same thing as 2 over n to the n. And now you're in great shape to apply the root test. So if you still haven't, take a moment and do it. Pause the video, start it back up when you're ready. Applying the root test, we take the limit as n goes to infinity of the nth root of these terms. So the nth root of 2 over n all to the n. And the nth root of something to the n is just the something. And so we get the limit as n goes to infinity of 2 over n, which is equal to 0. And since 0 is less than 1, we get that our original series, the sum n equals 1 to infinity of 2 to the n over n to the n, converges by the root test. Okay, that was the root test. Congratulations. As I mentioned before, that was the last of our series convergence tests. There is, of course, a homework on the root test. I should warn you, not all of the questions actually require the root test. The homework takes advantage of the idea that you know all of the series convergence tests. And so there's at least one question that sort of mixes and matches them together. So be watching out for that. Have some fun. Looking forward to seeing you in class.